Liceo Math Club. In this video, we're going to learn about another one from General Mathematics, and we're going to learn a chapter here under the basic business mathematics. Specifically, we're going to tackle today actual and approximate time. That's a topic under the simple interest environment. By the way, this is our aide, the club's moderator, and I will be the one presenting this topic to you guys. Okay, so this video must be right after you watch the ordinary and exact interests. This is the third, I believe, or fourth of the video video lessons under the simple interest or under the basic business mathematics chapter of the general math. So um, the term of the loan may be computed from the origin date to the maturity date. So, for example, you know that I equals PRT in the simple interest environment. So I equals PRT. Time, we know that in our ordinary and exact interest, time could be in days. And in that moment, we're given the number of days actually, not dates. Okay, so the number of days, for example, you're going to pay it in 10 days, 20 days, 360 days, or any of that sort. But here, we're given the origin date. So it's a date. Say, today is June 1, 2020. Okay, that's at the origin date. You're going to pay it next year, June 3, 2021. So how long, what's the term of your loan? How long will it be the time in that case? So we're not given the specific number of days, but we could compute it given the origin and maturity days. So we have two types of time here, given the number of days, the actual and the approximate. So actual time is also called exact in some books, but let's try not to use the word exact so that we won't confuse ourselves with exact interest. Okay, so actual time or exact time is different from exact interest. Okay, so actual time is obtained by counting every day except the origin date within the term. So we're going to count it actually. Okay, so that is exactly what is written on the calendar. So we're not going to approximate, we're not going to round off. Okay, compared to the approximate time where we round off. So approximate time can be obtained by assuming that each month has 30 days. Okay, so including February, every month has 30 days. Okay, here in the actual time, we really count them one by one, but in the approximate, we will try to, from the word itself, approximate it that it has 30 days. Every month has 30 days. So just one more thing to note in the actual time or in the exact time. I told you we're not going to use the word exact here as well. So remember leap years in actual time because in leap years, um, well, we know in our everyday science that 1 year is equal to 365 and a four in a quarter day. So that's 1/4, right? So in our ordinary calendar, we try to omit that 1/4. So because when we round off 0.25, it just became 365. But then that quarter will try to accumulate itself every 4 years. A quarter times 4 is 1, correct? 4 times 1/4 is going to give us 1. That's why every 4 years we will experience this 1 day, an additional day in February. That's February 29. So that every time we see that February 29, we call that year a leap year. So that's why it's being counted every 4 years because again, a quarter times 4 is going to give us 1 day. Okay, and take note, leap years happen in multiples of 4. Okay, so we have no problem in approximate time since we only approximate all the days in the month to be 30. We have some, certain problems in actual time because our number of days in a calendar is 30, could be 30, could be 31, could be 28, seldom 29. So just take note that in our calendar, you may check it now if this is correct, but I'm sure that this is correct. There are 4 months with 30 days. Okay, so we have April, June, September, November chronologically. So those are the months with 30 days, and we have the rest to have 31 days, except for one special case, okay, which is February. In February, we know that it has 28 days, except in leap years that it has 29 days. Okay, so you may pause this video and have a copy of this. So we have April, June, September, November, that's 30 days. Otherwise, it's 31, except February. Okay, I believe some of your teachers way back then, when you were just still counting days in a month, they have that knuckle figure. Okay, in that knuckle, you may point on. You can imagine. You may do the knuckle thingy also there in yourself by yourself. So if you're going to have your knuckles, the first um, knuckle, how can I call this? The bulge on the knuckle of your, what I call this, a pointing finger is January, stands for January. Next, we will have some hole there, which is between your fingers, between your middle finger and between your pointing finger. That's your February. That's why it's not 31, because there's no bulge there. If we're going to move another, meaning I'm in the bulge of my middle finger, that's the March. That's why March has 31 days. And then I'm going to move another one. I'm going to have a hole between my middle finger and my ring finger. That's the April. That's why April is here. And you may follow this pattern, and you may remember your math teacher way back then in your elementary school years, and then try to remember how to memorize this effectively. But try to think that there are only 4 days with 30 days, and the rest are 31, except for February. Okay, so let's have some two examples before we finish this video. Say we're going to find the actual time and the approximate time from July 19, 2010 to November 15 of the same year. Likewise, in number 2, find the actual and approximate time from July 19, 2009 to November 15, 2013. So this is not the same year, but we're going to use the same dates for um, illustrative examples. Okay, so let's start with number 1. Again, we're going to find approximate and actual. I tried to make this a bit opposite. We're going to start with the approximate. Can we do that? Because it's much easier, and then we're going to compare it with the actual. So for the approximate, we are asked to find how many days are there from July 19, 2010 to November 15, 2010. So we're going to count. Okay, so you may count it manually on your calendar there, but it will take like a, a couple of minutes, say an hour to do that. If you're going to compute these two, and then, given you have a lot of mistakes along the way, and people do mistakes, but you can do this analytically. Just imagine July 19 to the next month is 30 days, since it's approximate, right? So July 19 to August 19 of the same year is equal to 30 days, right? This is 1 month. 1 month has passed. So this is equal to 30 days from the approximate time definition. Okay, now let's move on from August 19 to the next month, that is September. So August 19 of the same year to September 19 of the same year will give us still 30 days, since again it's approximate. Okay, moving on this pattern, September to October will still give us 30 days, and October to November is still going to give us 30 days. But whoops, look at here. We overshoot. Okay, because we should stop on November 15, not November 19. So we overshooted for how many days? Say 19 minus 15, that's 4 days. So since we only want until November 15, so we're going to put here minus 4. Okay, so what are we going to do? We're going to add all these months and then just minus the overshoot that we did. So what we have is 30 plus 30 plus 30 plus 30 minus 4 is equal to 116 days. So that's the number of days when we use the approximate time. Hopefully it's clear now. Next, we're going to compare it side by side with the actual. Okay, so in our actual time, we need to count every day of the month. So we need to consider 31 days, 30 days, or 28, 29, whatever days. So how many days are there in July? Is it one of the 4 which has 30 days only? Not quite. So therefore, July 19 to August 19 on your calendar right now, July has the 31st day. So therefore, July 19 to August 19 is equal to 31 days. Okay, how about August to September? Okay, August to September. August, if you're going to check your calendars again, it has 31 days. So therefore, August 19 to September 19 is still 31 days. Okay, let's move on. September 19 to October 19, 2010. the same year. So check your calendar. September only has 30 days. Okay, so since September only has 30 days, we're going to put 30 there, not 31. And lastly, October 19 to November 19. October has 31 days, so we're going to count that as 31. And again, we have a deficit, or rather an overshoot of 4 days, so we're going to put -4 there still. Okay, so after that, so we're going to add 31 plus 31 plus 30 plus 31 minus 4 is going to give us 119 days. So we can see that in actual time, it has more time compared to the approximate, since we're counting 31s. Okay, we're counting 31s of the day, so most of the time, it will be more. That's more number of days than the approximate. Okay, so again, 116 for approximate. Actual time is 119. Okay, I hope that's clear now. Let's go to number 2. Number 2, you're asked, find the actual and approximate time from July 19, 2019, or 2009 rather, sorry, to November 15 of 2013. Now, if we're going to do this monthly, well, it will take us quite a lot of time, since in every month you need to count. I mean, my goodness, no, we won't do that. So we have a trick here wherein from 2009 to 2013. So we're going to count now, since we have a difference in the year, we're going to count by year. And using approximate, using that knowledge of approximate time, we have 30 days a month. How many months are there in a year? That's 12. That's non-trivial. 12 times 30, okay, is going to give us 360. So therefore, July 19, 2009, going 1 year on that same date, okay, we have, we have made 1 year already here. So we have July 19, 2010 now. So that's 360 days in the approximate time, since every day is only worth 30 days, or rather every month is only worth 30 days. Okay, let's go to another one. We didn't reach 2013 yet. So July 19, 2010 to July 19, 2011 is still 360 days since it's approximate. Let's continue in this manner. 1 more year up until 2012, that's 360 days. And then let's reach until 2013, and then we have 360 days. Okay, so if you're going to notice, the months, the dates are still the same with number 1. That's for illustrative purposes, July 19 to November 15 of the same year. And notice we are already on the same year. So we're going to use the answer we got from number 1 and the approximate time, since this is approximate. So we're going to use that from number 1. We know that there are 116 days from July 19 to November 15 of the same year. So we're going to use that knowledge. So what are we going to do? 360 plus 360 plus 360 plus 360 plus 116. So hence, there are 1,156 days from July 19, 2009 to November 15, 2013. Okay. Hopefully that's clear now. Let's move on and compare this result to the actual. So actual, we will really need to count the number of days per year, the actual, okay, from the word itself, the actual. So July 19, 2009 to 2010, let's check. Is it a leap year? Because leap years are very important. It's very critical to question if it's a leap year or not. Because if it's a leap year, we have an additional day of February 29. So therefore, it's not going to be 365. It's going to be 366. Okay, so this is 365 since 2009 is not a leap year. And we passed through 2009. Okay, or rather, February 2010 rather. So 2010 is not a leap year. Sorry, I meant 2010. So since February is found here. Okay, so since 2010 is not a leap year, we don't have a February 29 here, so therefore that's only 365 days. Going on to the next step, so again 2011 is not a leap year, so therefore we only have 365 days there using actual time. Okay, again, let's move on here. Let's go to July 19, 2011 to July 19, 2012. Now, let's try to think of this for a moment. Where did February go? I think February is in here till July. It's before July, right? So February must be here. So February 29, and this is 2012. 2012 is a multiple of 4, right? Okay, so 4, 8, 12. So 2012, right? So therefore, this 2012 is a leap year, and February is found here within this July 19, 2011 to July 19, 2012. So therefore, instead of 365, it's going to become, okay, so it has 366 days because of the leap year. Okay, so that's 366. Okay, let's move on here. So we have 2012 now on July, going to 2013. So um, February is found here. So 2013 is not a leap year, so therefore we're going to settle with 365 days then. Okay, so we have reached the same date with the November 2013. We're now on July 19, 2013. So since we're on the same year, rather, we're on the same year, so we're going to use the answer from number 1. So from number 1, on the actual time, we know that there are 119 days using the actual time. So what are we going to do? Let's move this up a little bit. We cannot fit the screen. What we're going to do is we're going to add all of these: 365 plus 365 plus 366 plus 365 plus 119. We have 3 365s, 1 366, and plus 1 119. We're going to add that and sum it up. The answer is 1,590 days. So that will be our answer for the actual time. Okay, so simply comparing both between the approximate and the actual time, so we can see that there's a massive change, a big amount of days, which differs from the approximate time, and that difference is more than 30 days. Thinking of 30 days, that's more than 1 month. So 1 month is a big number of days, right? So there's a big difference if we're going to use approximate versus actual. So you should make sure that it is clear for you as a lender or for you as a borrower, whatever, right? So it should be clear whether to use approximate or actual. Okay, so we're done with the approximate and actual time. We're also done with the ordinary and simple and rather exact interest. So we can classify the types of interest here. So we have 4 classification. That was some teaser there. 4 different time factors for possible are possible for simple interest. So for the ordinary interest, we could, in the ordinary, remember ordinary interest, that we're going to um, equate the time, the t time, as number of days divided by 360. Okay, again, number of days divided by 360. So that number of days is made clear here in our topic, actual and approximate time. So we could use, under the ordinary interest, we can have 2 time factors further. That is, for ordinary interest, the following time factors are used. It's either you use actual time for the number of days over 360, or number 2, we use approximate time over 360. So that's 2 of the 4 classifications actually. Second, if we have exact interest, remember exact interest, we're going to divide the number of days by 365. So we could use again actual and approximate in that as time factors. So number 3 is actual time over 365, approximate time over 365. Okay, so and these are the 4 classification of interest in the time factor of interest we're going to use all in all. There's no other combinations of other factors of other time factors actually. Okay, so you ask what is the one that's the default. So ideally the problem should have stated what to use, but seldom, if ever the problem did not state what to use, we have here some remark. The first factor, this number 1, actual time over 360, is also known as the banker's rule. Okay, it's called the banker's rule because if we're going to use a specific problem and then we try to use any or all 4 of this as the factor for the time, the one that will yield the most interest is this, actual time over 360. We call it the banker's rule because it will give you the most interest actually. So that's why it's mostly used in banks, from the word itself, banker's rule, because banks could have a lot of interest there compared to the other 3 factors. So this is used when the problem does not specify which time factor to use. So this is our like default. Okay, so if ever the problem gives us two dates, an origin date and a maturity date, and then did not specify what to use, so we will use this actual time over 360. Okay, hopefully I got it. And this ends our video for today. So thank you for listening. This is our again actual approximate time. Hope you like this video. If you do, give us some thumbs up there. Try to subscribe in our YouTube channel. That's the one you're watching right now. We are also on Facebook, so like and follow our Facebook page for more updates. We have a lot of activities there in our Facebook pages. This one is actually one of them. Okay, so again, thank you so much for watching. Hope you learned something from this, and yeah, we're doing a lot more rather. So stay tuned, and that's the reason why you should subscribe. Okay, thank you again. This is Sir A. See you soon.